Select the probability p for each histogram. So the different values of p that I have are 0.6, 0.45, and 0.3. Now, to determine which of these is which, notice there's the same number of trials in each of these binomial experiments. It's always 16. So something's changing here. We have n always as 16, but the value of p is changing. And these are really the only two inputs that you are required to make a binomial distribution. So how do we know which of these is which? Well, to give you an idea, to give you a visual, let's take up something that we can change very quickly and see the results. So we have 16 trials. Let's switch over to 16 trials, and let me put p as 0.5, and I'll just set all that. There we are. So notice that when I set p as 0.5, this distribution is perfectly symmetric. It looks very much like a bell-shaped distribution. But if I decrease the value of p, it starts shifting to the left. If I gradually increase the value of p, the distribution starts to shift back toward the center. Up to the point where I get back into the center. Okay? And if I go larger than 0.5, then the distribution starts shifting over to the right. And it actually doesn't make any difference how many trials you have. This would always be the case. So if I increase the number of trials to 20, if p is 0.5, you're always going to have a distribution that is centered. Yeah, sorry about that. And so if you shift things where p is larger than 0.5, everything shifts to the right. And if you change to values of p less than 0.5, everything shifts to the left. So that happens in any kind of binomial distribution. So that's what the idea behind solving this problem is going to be. So what I'm going to do is try and decide here which one's closest to the center, right? So the one that's closest to the center is this one here, right in the center. So the one that's closest to the center is going to be closest to 0.5. So I have 0.45, so that's going to be this one. So this is 0.45. Now, when I go for values that are larger than 0.5, everything's shifted to the right. So for instance, this one's a little bit further to the right than it is to the left. So this is going to be some value that is larger than 0.5. And the one that I have there is 0.6. So this is A. And if I have everything shifted to the left, then this one's shifted more to the left here. So this is going to be the one that is less than 0.5, which is 0.3. So this is C.